Okay. Okay. Let's see. So, what is sorting algorithm? First of all, sorting is again one algorithm. It's not the specific data structure. It is an algorithm similar to searching. It is an algorithm. So, why do we need sorting? First of all, so our main intention or the main thing that we are learning in this course is how to use data structures and why do we use data structures. So, data structure is nothing but an organized way of storing data, but sometimes the data might not be organized. Let's say the data might be something like this 23104. Okay, in this case the data is not organized. So when the data is not organized, our searching and traversal and all will be complicated, and it might increase the time complexity. So if you see, if I want to search zero, I have to go through all of them. I don't know where the zero will be. It can be any random index. So just to make our answer data set sorted or data set in to follow one particular order, we use sorting. So we will use sorting algorithm to make it in a particular order. So 0, 1, 2, 3, 4. So this makes our logic predictable. So once we are at 1, we know that all the elements on the left side will be less than 1 and all the elements on the right side will be greater than 1. So in this way, we can write some efficient algorithm. So even if you remember, uh, binary search works on a sorted array. So binary search will not work on unsorted array. So if you know that binary search time complexity is log n, whereas the normal searching algorithm is log n. So yeah, so depending on the cases, if you want to sort the data set according to one particular order and make it predictable, in that case sorting can be used. So what are sorting and how do we perform sorting? So basically sorting can be of two main categories. So first one could be comparison based sorting. Another one will be non-comparison based sorting. Non-comparison based. In comparison based sorting, we will compare one element with another one and decide whether they are equal or they are less than or greater than. In non-comparison, we will not do this comparison. So there will be no comparison. We'll check this element. We do some operations on it so that it comes and it is placed in the correct position. So and this is nothing but count sort comes under a non-comparison based sorting. In consort, we just count the number of elements, and then according to that number, we do it. We do the sorting. Again, this is very it solves only very small range of problem set, but comparison based sorting is the one that we will be mostly looking into because this is more robust and this is more efficient as well. Okay, so now let's see what are the sorting algorithms that we are discussing today. So in general, sorting has a few algorithms. Let me write it. It's bubble sort, then insertion, then selection, then quick, then merge, and then another one important one could be heap. Okay, there are many sorting algorithms. So why are we learning all the sorting algorithm? Can't we learn just one? Yes, you can definitely learn one. But why are we learning all of them is because we want to understand how each one of them work. From each one of them, we get to understand an algorithmic approach. So in bubble sort, there is some different approach. In insertion sort, there is some different approach. So with this approach, our mindset will be free to think in all those directions. So whenever we see a problem set, we can think in these mindsets as well. So bubble sort, quick insertion sort, and all can is not only a sorting algorithm, but these terminologies can also be implemented in few other problem solving questions. That's why we are looking into all of them, and also in looking into all of them, we can understand why they are different and how they are different, and which one is the most efficient one. So, sorting, and everyone knows the definition, but how to implement and what is the small differences between each one of them, it is something that is important, and y- something that you can explain easily if you know the details. So if the interviewer asks you, so what is the difference between quicksort and merge sort? If you don't know their implementation in detail, you cannot answer this question. So that's why you will just go through all of them and understand how each one of them works. Any question? So bubble sort, let's start bubble sort. Tell me what is the bubble sort algorithm? How does it work? What is the approach in bubble sort? This is the array, let's say. This is the array. How does bubble sort algorithm work? Bubble sort is one of the easiest algorithm to implement. So how it is done? So yeah, so bubble sort is one of the easiest algorithm, guys. So the main trick here in bubble sort is it will just compare the adjacent values, and depending on the comparison, it will just swap the elements. So let's first see this. So it was this 3014. Okay, I just compare these two. So which one is, so 3 is greater than 2. So we just check whether these two, so the left, this element should be less than the right element. Left element should be less than the right element. So now in this case, left element is not less than right element. So we will just change this. So swap 23014. Now again we'll check this. So yeah, this is also not correct. 02314. Again we'll check this. Then it will become 02134, and then again I will check this. So once I do this check, this is again, it is in the correct position. 3 is less than 4. So in this case, if you see, with every iteration, my last part of the array is sorted. Then I will again continue my this thing, swapping or this sorting part. Then again I'll compare these two. Then which one is, this is not correct, so it is 02134. Then again these two. Then again 01234. Then again these two. This is already sorted. So this we will not continue with this part. So we will just stop it here. So first, in the first iteration, we have to go till this point. In the second iteration, we will only go till this point. In the third iteration, we will only consider till this point. So what is the value here? 0, 1, 2, 3, 4. And this part is already sorted. So we will just see till this part. So 0 and 1, it's not correct. Okay, 0 and 1 is correct only. So, okay, it will leave. So, and then it will be nothing. 0, 1, 2, 3, 4. Then 1 and 2, it is also correct. So it will just say that this part is sorted. And in the final iteration, I'm just writing it here. Let me write it here. So in final iteration 0, 1, 2, 3, 4. So we were going till this point. We will just see whether these two are sorted or not. Yeah, these two are sorted. So we can just simply say that this entire array is sorted. Okay, this is the simplest algorithm, guys. So in every iteration, so if you see, this is my first for loop, I would say. So I need a for loop which runs, outer loop should run this many times, 4 times, and inner loop should also run these many times. So we can just implement two for loops and do this bubble sort algorithm. So all you have to do is compare the adjacent element every time, and based on their values, we have to just sort them. And with every iteration of outer loop, we make our last parts of the array as sorted. If you want, you can make a. If you want, you can uh, take a look into this thing and note it down somewhere for your reference. So everyone good with this bubble sort algorithm? So as you know, as the name says, bubble sort means bubbling. So in a water, if you see if there is a bubble, it will just go to the top, right? So similarly, we start a bubble here, and then it just keep checking, and it will go till the end, and then it will just keep checking, go till the end. So every time we have to do this. Let's see how we can do the code for this thing. Let me. So let's say. Okay, let's write a code here. So we will create, first of all, we will take an input array. So int n. So first we have to create a scanner object. In dot next int. Then we will create the array of size n. Okay, done. So I am just printing the array value just for my reference. System dot out dot print arrays dot sort. Arrays dot to string of take my array. Okay, so we will just check whether we are doing the correct logic or not of taking the input. Okay, let's give the input. Let's say 5, 3, 2, 0, 1, and then 4. See, 3, 2, 0, 1, 4. So it is taking the input correctly. Now we have to implement a sorting algorithm. So let's say, and there are two things, guys. First, you have to remember there is in place sorting, and there is there is a sorting where you cannot modify the input array. If you cannot modify the input array, you have to create duplicate array and then you have to do the sorting there. But all the sorting algorithms that we will run today is in place. That means we will change the given array. We can pass the error, or you can simply write it void because we are not returning anything. Bubble sort, and it takes an array. So simply I can do something like this, int I is equal to 0. It starts from I and it will go till n. So arr dot length I plus plus. So now j also starts from 0 because if you see every time we start from 0 all the time, and then j is less than length minus I minus 1. So why did I do minus 1 is because we are just comparing it with the last value. So in that case we will do a comparison of j plus 1. So just to avoid that out of 1 exception, we are doing minus 1. And why this minus I? Because every time with this for loop, if you see, every time with this for loop, my last boundary is shifting. So here I was 0, so it was that's why it is going till length minus 0. Then it is 1, so it is going the last index minus 1. Then it's going then it was index 2, that's why it is going last index minus 2. Okay, for so on. Could you please explain toString method? ToString is just a utility method that Java is providing. If you want, you can check it from the documentation. So it will be util dot arrays. So just check the documentation and you will understand. See this. So toString, what is it? Returns the string representation of contents of the specified array. So it is just a simple method which reprints the entire array, or which gives the string of the entire array, string representation. Sorry, yeah, I. So for I is equal to 0, I less than array dot length I plus plus, and j is equal to 0. So if you see, let's go back to our diagram. So j always starts from 0. So this is nothing but j. J is starting from 0. Then again it is starting from 0. So from 0 we have to go till this point. So what is this point? This point is nothing but last index minus I. Last index minus I. So this is done, okay, understandable. But why minus 1? Because we will not actually go till this point, we will go till this point, and we will compare these two values at the very last. That's why it is minus 1. So okay, now we have to do the comparison. If ARR of j is greater than ARR of j plus 1, okay, so if left value is greater than the right value, then we have to swap the elements. So we know how to swap it. So in term we will use the third variable here. Done. So with this we will sort the array. So let's now sort it. I will say bubble sort, take my array. Okay, so it is expected that it will sort in place, and then I'll simply print it. Okay, let's see. I don't do j plus plus. Okay, j is equal to 0, j less than this and that. And we have to declare j int j. See, 32104 and 01234. So this logic is the very simplest one to implement and the easier one to understand as well. And this is sorting my array correctly. Okay, any questions in this logic? So if you see, it's a very simple logic. All we are doing is your first loop will run n times. So if you see 1 time, 2 times, 3 times, 4 times. So 1, 1, 2, 3, 4. So we can also decrease it by -1, but if you want, you can do it anyhow. If you don't do it, this loop will fail, so nothing will happen. Even in this case, if you see, this will work. Okay, so this for loop is running n-1 times, and this inner loop is also depending on n minus I minus 1 times. So based on this, we are just comparing the adjacent values. So any questions in this code walkthrough? Come on, guys, let me know if you understand this, or you need some more explanation. Okay, so now there is one thing that we will see. So what is the time complexity basically? So basically time complexity is, I think this is running 4 times. When I say running a comparison here, the main logic is we want to see how many times these statements are executed. So these statements executed here 4 times, then here 3 times, then here 2 times, then here 1 time. So we already know this series. This is nothing but n minus 1, n minus 2, n minus 3, so on till we reach 1. This is a series of n into n plus 1 by 2. So the time complexity is nothing but n into n plus 1 by 2, which is nothing but n square. Okay, so the time complexity of bubble sort is n square. And are we using an extra space? No, we are not using an extra space which grows in according to the input size. We are just using a temporary variable which is a constant space thing. So the bubble sort time complexity would be order of n square, and then space complexity will be order of 1. Okay, so can we improve it a bit? Can we improve this bubble sort a bit? So let me give you a case. Let's say 1, 2, 3, 4, 5. If my array is like this, so according to our logic, so we will start our comparison like this. So 1 and 2, okay, nothing changes. So and then 2 and 3, nothing changes. 3 and 4, nothing changes. 4 and 5, nothing changes. So with this, our 5 is sorted. Then again we do 1, 2, 3, 4, 5, then 1 and 2, nothing changes. 2 and 3, nothing changes. 3 and 4, nothing changes. So 4, 5 sorted. If you see, even if it is sorted, we are just continuing our search unnecessarily. So we can do there is a scope of improvement here. We will just check whether there is a swap happening in this particular loop or not. This particular is nothing but this outer I loop. So I have to check that. So I can just simply do this boolean is swapped is equal to false. So if the swapping is happening, then I will just say is swapped is equal to true. Okay, so if there was no swap, then I will just simply return, because once there is no swap means it is already sorted. If you see in this situation we are not doing any, so that means this array is already sorted. No need to continue further on the I executions. So these executions are not required. So that's what we have written it here. So it will just take basically check for, so if it will just taking, it is just taking a boolean variable is swap, assigning it, and we are just checking if this variable is not assigned, that means it is still false and it is true, and not of false is always is again true. So if this condition is satisfying, it will just return, it will just break the loop, or you can simply say break also. So break will break it out from the for loop and it will eventually end. So but I'm just saying return. Okay, any questions here? So with this, my worst case complexity, time complexity wise, if you see time complexity, the best case is best. I think it is represented by omega. Best case is 1. Worst case is order of n square. Best case is when it is already sorted for sorted array. And average case is also order of n square. Order of n square. Space complexity for all the cases it is order of 1. Okay, so this is the time complexity and space complexity of this thing. Average use theta, I guess. Let's check. Yeah, omega is used for best case and theta is used for average case. Yeah, so this is the time complexity, guys. Let me know if you are following or if you have any questions. We'll share the code with you. This is the bubble trick. Come on, guys, be responsive. Try to respond in chat. Okay, now let's move to the next sorting algorithm, which is nothing but selection sort. We'll do selection sort. So let's see what it is and how it is. So let's go on. So in bubble sort, what is the disadvantage first of all? So in bubble sort, we are always doing this comparison. So this comparison is happening, and whenever we see a comparison, whenever we see a situation that is failing, we are just swapping. So in worst case, we might end up doing n-square swapping. So this is the drawback of bubble sort basically. Uh, in a case where the write operation, basically the write operation to the memory is very costly, and if you're constantly doing swapping, then it becomes little tedious and it becomes little slow. Bubble sort will become a little slow. In that case, we have this sorting algorithm of selection sort. So let's start selection sort. So again, we will take the same array 3 2. What was the array? 32014. 32014. So in selection sort, what we are doing is let's start. So 32014. So in selection sort, we again similar to merge bubble sort, we maintain some sorted array and unsorted array. So in that part, we are just so technically this entire array is not sorted till now. So in selection sort, we will select the smallest element of this unsorted array. So what is the smallest element? 0. So we will put this 0 to the first available index and we will swap the values. So it becomes 3, 0, 3, 0, 2, 3, and 1, 4. If you see this part is sorted, then we'll continue our sorting algorithm 0, 2, 3, 1, 4. And this entire part is unsorted. In this entire part, what is the smallest element? 1. So we will swap this element. So it becomes 0, 1, and then 3, 2, 4. If you see this entire part is sorted, then again we'll continue. The selection, as the name say, so we are selecting the smallest and putting it in the correct position. We are selecting this every time we select the smallest and put it into its correct position. So let's continue 0, 1, 3, 2, 4. Which part is not sorted? This part is not sorted. What is the smallest here? 2. So we will swap it with the available index, next available index 0, 1, 2, 3, and 4. Okay, so now it is 0, 1, 2, 3, 4. So which is not sorted? This is not sorted. And what is the smallest? 3 is the smallest. So we will just try to swap it with itself only. So 0, 1, 2. We can just avoid this corner case also by checking the indexes. But once we sort it, it becomes 3, 4. And once this entire array is sorted, so this was sorted here. Once this array is sorted and we are left with only one element, obviously this is sorted. So this is nothing but our overall array is sorted now. So our overall array is sorted. So if you see, this is how selection sort works. We are just taking the smallest value and putting it into its correct position. You can take a note of this diagram if you want, so that you understand and remember them. Okay, so let's move on with the code. Everyone done with this notes? Okay, let's move on to the logic. So it will be public static bubble sort, right? So we are doing a selection sort. Public static void selection sort. So again, it will take just an integer number. So integer array int arr. There is no change in the method signature. I'm just minimizing it. So again, the same thing for int I is equal to 0, I less than arr dot length uh, -1, because obviously the last part will be sorted anyhow, I plus plus. Okay, now I will say int min index is equal to, for time being I'm saying as I. Now again I have to go from int j is equal to I, j less than arr dot length j plus plus. Okay, so if you see we can go from I or we can go from I plus 1 as well. So if let's do it. So if my arr of I I would say no, if my arr of main index, if it is greater than arr of j, that means the value, or in other words, if my arr of j is less than my main index, so now I need to change my minimum index. That means this element is the smallest, so I just quickly update it. Main index is equal to j. Simple. Okay, so this loop will find me the all the small, with this loop will find me the smallest element from I to the end. So in this case, if you see, we are just unnecessary doing the first comparison. So let's say j is equal to I, so it will be I. Okay, indirectly I, and min index is always I. So we are just wasting one comparison, so we can just improve it by doing I plus 1. So compare it to the next element. So j will always start from the I plus 1. Okay, so this will work now, and as you know, we will get the minimum index after this for loop. So once I get the minimum index, I have to sort it, so swap it. So I will just simply say that int temp is equal to arr of I, and int arr of main index is equal to arr of I, then arr of j should not go till the length -1, guys. J should go till last value, because if you see here, we are having our sorted array in this way. So our j, or the inner loop, should always go till the last value available. So it should always go till last value. It should always go till last value. Okay, so we cannot do j less than -1. We cannot do like this. If we do like this, our last element will be skipped. So arr of I is equal to temp. Okay, done. So this will do the swapping, and let's test it out. In place of bubble sort, I will say selection sort. Okay, so there is something wrong. So in temp should be main index. In temp is equal to main index is equal to a of I is equal to temp. Yeah, 0, 1, 2, 3, 4. You see, it is already sorting. So there was one case that we see. If you see this, 3 is the minimum index, and we are trying to swap it with 3 itself. So in that case, we can add a check. So the main intention of selection sort is so that it doesn't do more number of swappings. So, but if all the elements are already sorted, so it will unnecessarily do the swapping. So we can just add one case here. If my min index is not equal to I. Okay, when both the indexes are different, then only we will do the swapping. That's it. Okay, so this is how a simple selection sort works. If I just run, there will be no change in output. 0, 1, 2, 3, 4, 5. Clear with this approach, guys? Selection sort, the code and to the walkthrough. Okay, so there is one thing that you should remember. In this selection sort, we have to definitely, in every time, that means in every case, we are going or searching the minimum value, even if the array is sorted. Let's say the array is sorted 1, 2, 3, 4, 5. This is the best case that I'm talking about. And even in the best case, I'll just search the smallest value. It is 1. So I'll just swap it. And then the next for loop, I'll search it. I'll just search the smallest, then I'll swap it. So though we are avoiding this swap, but we are doing these operations. We are doing the operations to find the minimum value. So that's why even in the worst case scenario, my time complexity of selection sort will be n square. So selection sort, best case is n square, because we don't know if we are not doing any optimization depending if the array is sorted or not. So if you remember in quick sort, sorry, in bubble sort, we were comparing. So if there was no swap happening, we were just breaking. But now in here, we don't know. We are just looking for the smallest. So every time we have to look for the smallest. So it best case also n square. So best case it is n square, n square. Um, and then what is this? Average case is also n square, and then worst case is also n square. And space wise, if you see, space is nothing but order of 1, because even here we are not using any extra space. We are just doing in place operations. Sending you the code. Let me know if you understood it or you need some explanation. Okay, these are the time complexity of quick selection sort. Keep a note. The selection sort, as the name suggests, we are selecting the smallest element and putting it into its correct position. Can we include a check for sorted array? In selection sort, it becomes very difficult. In selection sort, we cannot do it. If you want to keep a check, you have to write a for loop again. So if you want to just keep a check for the sorted array, we have to write a for loop here. So some separate for loop, which will do the checking. So this will do the optimized case, but obviously that is like our adding an extra piece of code. So within this logic, we cannot identify if it is sorted or not, because every time we are checking it with the minimum index. If you in here, if you see, we are always checking for the minimum value. So we cannot just identify if it is in sorted order or not. Can we move ahead, guys? Okay, let's see the next sorting algorithm, which is nothing but insertion sort. How is selection sort better than bubble sort? So selection sort is better because selection sort will not do n square swapping. It will at max do. So selection sort, if you see, at the very max, selection sort will do n square mapping. So this swapping logic is written in the outside loop. So that's why the swap will happen at the n times at the worst case. But here in the bubble sort, if you see, the sorting logic is written, or the swapping logic is written inside the inner for loop. So the swapping may go n square time. So that's the first point that I said. So whenever there is a system where the write operations are more costly, swapping is nothing but we are writing the value. The write operations are more costly. In that case, selection sort could be preferred. But again, if you compare time complexity wise, both are same. Both are n square operations. Okay, let's do insertion sort. Let's take the same array: 3, 2, 1, 0, and then 4. Okay, in selection insertion sort, we take a number, and so we maintain two parts as same, just like the one we have seen in bubble sort and quick sort. So it maintains two parts. So one is sorted array and another one is unsorted array. So it takes a number, puts it into its correct position in the sorted array. So what do I mean by that is 3, 2, 1, 0, 4. So 3, 2, 1, 0, 4. Okay, so it is sorted. Basically this number is sorted, so it will take 2. It will just go till I get the correct position in the sorted array. So 2 is greater than 3, so obviously it should move here. So after doing this, it becomes 2 and 3. I will explain you the code how it works, but after this operation, this is sorted. This entire thing is sorted. So now we will start another loop. 2, 3, 1, 0, 4. This is already sorted. We will just check with this one. Okay, so 1 is less than 3, so 3 will come here. Okay, then 1 is less than 2, then 2 will come here. Okay, once it is done, then it is 2, 3, 2, 3, 0, 4, and then we are moving 1 to this position. Okay, so then if you see, this part is sorted now. So it is 1, 2, 3, 0, 4. This is sorted anyhow. So we are just checking the value now. So 0 is less than 3. So we will move 3 here. So 2 is less than 2 is less than 0. 2 is greater than 0. We'll move here. 1 is greater than 0. We'll move here. So we are just shifting our elements one by one. So 0, 1, 2, 3, and then 4. So nothing but you are taking 0 and inserting into its correct position. Okay, as the name say, insertion sort, we are taking 0 and inserting into its correct position. So now it is 4. So 0, 1, 2, 3, 4. Okay, now all we have to do is check with 3. So 4 is greater than 3. That means we need not to check in this side. So it is already in a sorted position. So we will just return sorted. Okay, so this is how it is working. So let's take a different example so that you understand how it is working. So let's say 3, 1, 2, 0, 4, 5. Okay, in this case, so 3 is already sorted. 0, 1, 2, 0, 4, 5. If we say, so 3 is already sorted. So compare 3 with 1. So 1, so we will store the value that we are comparing, 1. Okay, so in now check, 3 is greater than 1. Yes, so 3 will move ahead. Now there is any other elements? No. So after this move ahead, something that my array is something like this, and my pointer is still here. So I will do 1 here. Okay, so this entire thing is now sorted. 1, 3, 2, 0, 4, 5. Okay, now this is done. Now 2 is the one that you are comparing with. 3 is greater than 2. Yes, so sorted. My index is still here. 2 is greater than 1. 1 is greater than 2. No, so it will break here. So after this thing, it will be something like this. After this swapping, it will be something like this. 0, 4, 5. But my index is here. So wherever my index is, I will just replace its value. So if you see, this is sorted. So now again 1, 2, 3, 0, 4, 5. So 0 is the value. We are just storing it in some variable, and then we are checking. So we have to check this part. So 3 is greater than 0. Yes, swap. 2 is greater than 0. Yes, swap. 1 is greater than 0. Yes, swap. So at the very last, my pointer is here and all my values are swapped. So that means it will be something like this. 1, 1, 2, 3, 4, 5. Okay, and then I have 0 stored. So I'll just replace it here. So 0, 1, 2, 3, 4, 5. So this is how I'll get this part as sorted. And similarly, this pattern continues. Okay, we are just taking a number, putting or inserting it into its correct position. You can take a note of this thing so that you understand or you remember. So this is kind of similar to bubble sort. Both the time complexity is also same for bubble sort and insertion sort. So again, even here, there might be case of doing n square swapping. So nothing is actually improving here. It's just a simple or another way of looking into a problem statement. Okay, let's see the logic. So I will do logic. Insertion sort, it takes an array. So first things first, I need to start from 1 because 0th index is anyhow sorted. So int I is equal to 1, I less than arr dot length I plus plus. Okay, so now I am just checking. So I have my index values. I'll just store it here. Int number, something like this, ARR of I. So this is the number that we are trying to compare with. Okay, and then this is the number from where I should start my comparison, I minus 1. So if you see, if my I is here, I should start my comparison from I minus 1. If my I is here, I should start my comparison for n minus 1, this way. Okay, so if my I is here, I should do the comparison this way. My God. Sorry for the background, guys. Can't help it. So j is equal to I minus 1. So now all you have to do is while j is greater than or equal to 0, that is a boundary condition. J can go till the 0 thing. Okay. And so see this is the most important thing. While j is greater than 0 and array of j is greater than value. So as I said, right, so if 3 is greater than the value, 2 was the value here, then we will swap. Now, if 2 is greater than 1, no, we will not do. So once we meet this condition, right, so let's say the condition is something like this. Let's say there is a value 1, 2, 4, and then we are trying to do 3. So we will have 3 store it. Okay. Now 4 is greater than 3, so we will swap. Now 2 is it greater than 3? No, that means we will stop at this position only. We will stop here itself. We will not continue this side because we know that already it is sorted. So all the elements here will be less than 3. So that's why array ARR of j till the value of ARR of j is greater than the value, will continue this shifting operation. Shifting operation is what? Take the j plus 1 and put it with j, and then j minus minus. Okay, so I'm just moving one step ahead. So whatever value is there, I'm just shifting to the j plus 1. Whatever value is there, I'm just shifting into j plus 1. Okay, so once this is done, I will just do the actual shift. So this number is there, right? You have to insert it here. So where should I insert? J will be pointing to the insertion index. So ARR of j is equal to num. By j plus 1, because it is decrementing every time. Okay, so this will actually solve my problem. And if you see, even here we are doing swapping. So this is nothing but read-write operations. So we are writing the logic n squared time. So this might go till the very last worst case complexity will be n squared. So kind of similar to bubble sort. So let's run this thing. I will say insertion sort, and the output should be same. Value is not there. Insertion see this 0 1 2 3 4. Okay, so it is getting sorted according to our this thing, our comparisons. Clear, everyone? So we are just making note of this number. Understand this, we are making note of this number, and then at the very last we are swapping it. Okay, until till this time we are just going and checking in the left side array at what index should we should we insert it. So till that point we are just shifting our elements to the one element to the right side. Okay, this is how the logic is for insertion sort. Let me give you this thing. So worst case complexity, even in the best case complexity, 1 2 3 4 5. So it is sorted. We'll try to insert this 2 will not go. So best case will be n, if you see. So best case here, how is it n is? So the order of n, if you know. So if this is the best case, okay, so 1 is already there. We try to insert 2 into the left side array. When we try to insert, the first condition itself will fail. So 1 is not greater than 2. That means this loop will never execute in the best case scenario I'm talking about. This loop will never execute. So it will just say, okay, it will just say that, okay, swap B here only. So it will just say that it swap here. And then uh, this is sorted. Then again, it will try to go into this left side. It will not, it will not be possible. It will not be possible. It will not be possible. So every time in the best case, it is order of n. So let me write the time complexity. Time complexity best is order of n. Okay, and then average. So average is nothing but n square only. It will be worst is also n square. Okay, worst is n square. N square. Space complexity wise, if you see, space complexity is order of 1 because we are not doing any extra space. We are not using an extra space, if you see. So how is it n square in worst case is, let's say we have something like this 4 3 2 1. So we take this 3, we have to go through the entire left part, so it will be 3 4. Then if we take this 2, we have to go through the entire left part, so it is nothing but we are again following the n into n plus 1 logic, which is nothing but n square. Okay, that's how this is the time complexities of this insertion sort. Everyone following? Is it clear? So if you see, if it doesn't enter this for loop, this j will be I minus 1, right? That's why we are doing j plus 1. So it will actually come back to its original position and do it. So that's the trick, or that's the implementation of insertion sort. So we covered 3 insertion sort today. Let me write the complexities. So bubble, let us write something like this: best, average, worst. It is order of n. Average is order of n square. Worst is also order of n square. We will also mention space. And then the next one was selection. So the best in selection is n square. Average also n square. Worst is also n square. Space is order of 1. Then insertion. Best is n. Average is n square. Worst is n square. Space is order of 1. Okay, so these are the 3 things that we have covered today. And I've also shared the code for all these cases. Okay, let's move on now. So the next topic for the day is Java inbuilt sorting. So, okay. So these are all the sorting algorithms that we have implemented. But let's say I don't want to implement this, or I don't remember, or I just want to save time. So for that, there is a simple thing, arrays.sort. This will sort your array. If you see, this will sort your array in ascending order. 0, 1, 2, 3. So let's see how this arrays.sort is implemented. So can you tell me, so if you see the signature is very same. So we are just passing an array, it is not expecting, or we are not returning any value, and it will do the in place sorting. Now you tell me, can someone tell me what is the time complex, sorry, what is the algorithms that Java guys are using in arrays.sort? Put your answers in the chat. So first of all, you tell me which sorting algorithm is the fastest sorting algorithm. So quicksort is the fastest one, guys. If you implement it properly, again, we will see how to implement quicksort in the coming sessions, but quicksort will be the fastest one. Arrays.sort is a overloaded method. The first thing to understand. That means in arrays.sort we can pass primitive values and we can pass an array of their objects. So whenever we're passing an array of primitive value, let's say integer, float, and all, then it is doing quicksort. Okay, very important point to remember. But whenever we are passing an array of integers, it is doing merge sort. So that is the difference here. So arrays.sort if someone is asking you, so the very basic answer you can give is arrays.sort uses a advanced version of quicksort, that is dual pivoted quicksort. We will see what is a pivot and all in the coming session. But if you want to give a simple answer, it will be arrays.sort use quicksort. But if you want to give a smart answer, you should do a counter question saying that what is the input array? Is it primitive type or is it objects? If it is an object, it is merge sort. Okay, how do I know? Because it is in documentation. You see this. Sorts a specific array into ascending numerical order. Implementation note. The sorting algorithm is a dual pivot quicksort. See this dual pivot quicksort by some guy, okay, some XYZ guy. This algorithm offers n log n. So the time complexity of arrays.sort is n log n. On many datasets that cause the performance to degrade to n square. So we will see this next part, and it's typically faster than the traditional one pivot quicksort implementation. So as a student or as someone who is all learning quicksort, we will see only one pivoted quicksort implementation. We will see that what is pivot and how do we implement quicksort. But just to give you a brief heads up, so there is something called as pivot, and we use this pivot to do quicksort, and we maintain only one pivot. But the Java guys have implemented it using dual pivot. So that means there will be two pivot elements. So what will happen here is quicksort worst case complexity annotation wise it is n square, but as they are using the advanced version, it is always maintain n log n. Okay, so this is for the integer array. So if you see for primitive types, it is quicksort. So for long is also primitive type, it is quicksort. See, so for short and all this is quicksort. For primitive type, basically it is quicksort. But say if there is integer, if I write, but if there is an object, that means let's object. See this. I want to. I'm more interested in this object. Why did I come here? So see this. So this is a sorting algorithm. Basically, this is a sorting algorithm which is taking an array of objects. Okay. So in this case, sort specified object in ascending order according to the natural ordering of element, and how this natural ordering is, you have to implement the comparator class and all the stuff. The sort is guaranteed to be stable. Equal elements will not be reordered as a result of the sort. Okay, fine. Implementation note. See this point. The implementation is a stable, adaptive, iterative merge sort. Iterative merge sort. We will see. We will do recursive merge sort, but these guys are doing iterative merge sort that requires far than n log n comparison. Far fewer than n log n comparisons. Okay, so in a nutshell, if the array is of object types, we are doing merge sort. Okay, and what is this merge sort? This merge sort is the implementation of by Tim Peter. So we also call it a team sort. Okay, you can just go through this sorting algorithm. Okay, he just gives you this entire sorting algorithm. Okay, so the main point here to understand is uh, for arrays of object, it will do merge sort, but for arrays of primitive type, it will do quick sort. Clear, guys? So how do I know? Because this is like official this is the official documentation of Java. So whatever is implemented, these that will be mentioned here. So anytime you have any doubt in Java, don't first go and search in Google. First check in the documentation. If you don't understand in the documentation, then you search in Google. So obviously, reading documentation is also a big skill, guys. So once you land into a job, let's say a big company or any service company or whatever it may be. So if you don't understand, there should be one official guide to help you, and this is that official guide. Okay, everyone clear with this thing? I just thought of letting you know because this is an important topic. That's why can you share the link of documentation? See this. This is the like the main page. In here you will see all the classes that is Java providing, and then from there you can learn about each one of the classes. This is the documentation link, and this is Java 8 documentation, by the way. Okay. So there is one thing. So let's say there is a. So we are okay. I'm just giving you a context here. So let's say there is a string array. Okay, this is hello, hi, hola, bonjour. I don't know what do we say. Okay, whatever it is. So this is how what I um, this is, let's say my array is something like this. Okay, so this is how many 5 elements, 2 elements, 4 elements, and then 1, 2, 6 elements. Yeah. So I'm just printing it first of all. So I'm just printing my array 2. I don't want this. Don't want this. Okay. So see, hello, hi, hola, and bonjour. Okay, fine. So this is done. Now I want to sort this array. Okay, so this, how do I do it? So integers, we know how we can do it. We can compare it. But let's say what will happen if I do this arrays.sort. So can someone tell me what will happen if I do arrays.sort? In which order will it be sorted? So this is an array. So this is an array of strings, and now I'm trying to sort it. So in which order will it be sorted? Ascending order, but what will be the output? So will it be output by the length or output by what will be the search criteria or the comparator? Yes, so alphabetical order. It is nothing but lexicographically it will sort it. Let's see. I was doing array 2. See, lexicographically it is sorting. Lexicographically means what? Alphabetically. Alphabetically means what? According to the order in which they appear in dictionary. So if you see, let me copy just this thing. Okay, so in dictionary, which word will come first? Which character will come first? Obviously, B will come first. So this word will be the first in the sorting. Then this there H, E, all of these are H. So again, next word, which one will come? E will come first, I think. Then H, hello. Then out of this I and O, which one will coming for? A, B, C, D, E, F, G, H, I, J, K, L, I. So then hi, then hola. Okay, so in this way it is getting sorted. So if you see hello, hi, and hola. So this is nothing but lexicographically. But how am I so sure that it will just do lexicographically? Because whatever you're passing here, if it is an array of object, that object should implement a interface called as comparable. So let's see what is that. So let's see string. I just want to see what string is doing. So in here, if you see string, it is to see implements comparable. That means it is having a compare to method. So now let's see what is that compare to method. Again, these are advanced Java. Once you understand this Java, you will be little good in this all understanding. So there will be some compare to method. I am just checking for that. Compare to. See, comparator, case insensitive order. See this comparator. Yeah. So in here, if you see, compares to string lexicographically, and this is what is happening. Okay, so this is how you should understand what you have to do. Let's say now I want to sort it according to the length. Okay, so the string which is having smallest length should be coming first. So how can we do it? So Java provides us this feature as well. So we can pass a new comparator as a next argument. We can see from this thing. So if you see sort uh, arrays dot sort, where is it? Yes, so this is all primitive types. So I'm interested in objects. See object and yeah, so there is a object and we specify comparator. So we can just give him our own comparator. String by default is having its own comparator, but that comparator is solving it lexicographically. But we want to solve it lengthwise, so we have to pass a new comparator. And this is how we pass a new comparator. So I can just say new comparator, okay, which is of string type. And this is like this comparator is again an interface. If you see, so see this. So string comparable. So comparable is an interface. Comparator is a class that is implementing that interface, but abstract class. So you have to write this logic here. So you have to write a logic which is public. It should return an integer value uh, compared to. It takes a string s1 method overriding. Again, that is a different concept. See this. So now I will return. So if you remember this, basically what I'm doing is I'm giving him a array. Okay, take this array and sort it according to this comparator. So I'm passing a comparator. So the syntax might be a little different for you, but stick to it. So we are passing a new object. We are creating a new object on the go. Right now, till now, we have seen how to create an object like this. Okay, so we are created object like this, but this being an abstract class, and we can just directly give it like this. Here we are changing comparator properties. Yes, we are actually method overriding is different, Ramesh. So method overriding is when we are actually inheriting something. In here we are not inheriting string or we are not doing anything. It is we are just leaving up to Java. We are saying that okay, take this comparator and you do it. He will take care of it. This is not method overriding. Method overriding is when we are in inheritance and we are overriding a method. So this will not be considered as overriding. So now I'm doing length minus s2 dot length. Okay, why I am what is this compared to? So compared to will take two elements. So what is the type of that element? Type of the element is the string. How do we know it is string? This string will be same as this array. Okay, this array is a string, that's why it is string. If it was some other object, let's say student object, so it should be student, and you should write a compare to. So if the student is having a comparable implemented, then it is not required. But if it is not there, then you have to pass a comparator. Okay, so we are passing this thing and I am doing this thing. Why am I doing this? So basically compare to method should return an integer. So an integer could be negative integer, 0, positive integer. So any negative integer means s1 should be coming in front of s2. Okay, that's the significance of this. Positive integer means s1 should be coming out means after s2, and 0 means it both are same. You can just maintain the insertion order. So this is the main difference. So negative 0 and then positive values. In a nutshell, if you want, let's say a and b are the first and second value. If you want it to be sorted in ascending order, just give a minus b ascending. If you want them to be sorted in descending order, just give b minus a. Yes, yes. This kind of logic is already means the same logic lies in so it is present in Java. It is present in JavaScript. I don't know. It might be present in Python also. Okay, so kind of similar. If a minus b means ascending, b minus a means descending. What is a and b? B is the second element, a is the first element. So what I'm doing is a minus b. That means I'm sorting in ascending order. What order? According to the length. Let's see if it works or not. It's not abstract method over it. This override, overridden. What do we write? My class does not override abstract method compare. Okay, it is compare, not compared to. Okay, see this. So it is now sorting according to the length. So H1 is of 2 length, Hola is of 4th length, Hello is of 5 length, and Monjo is of 6 length. Okay, so this is how you can do this sorting for objects as well. This is an important thing, guys. If you understand, so mostly when you're working in corporate jobs and all, no one will ask you to implement quick sort and merge sort. This is already done by arrays.sort. All you have to do is based on what property you want to sort it. Because if you know, quick sort, merge sort, and all are comparison based sorting. So comparison means we have to give him some indexes. Give him some parameters saying that this is less and this is small. How do we give them? By using this compare method. Okay, so Java is having this inbuilt feature. Again, depending on languages, this feature may be there, may not be there. So if I just change this, if I do s2.length minus s1.length, it will be in descending order, as I said. So bonjour, hello, hi, hola. Let's say there is a string of same length. Let's say it's something like ABCD. Okay, so this is of same length of 4 and 4. So in that case, it will maintain the insertion order. See, hola is coming first and then ABCD. Then 1, 2. Even in this case, the H hola will come first and then ABCD series. Okay, so in the when we are comparing these two, it will return 0. So in 0 means it will preserve the insertion order. So I hope you got this point. I'm just leaving it to the chat so that you can go through it later. Okay, there is one new feature, guys. So by Java 8, there was some Lambda functions introduced. So instead of writing this entire boilerplate, we can just simply say that we can simply annotate it like this. It will have S1 and it will have S2. Okay, so string 1 and string 2. All I have to do is return the value. So Java compiler will internally know that this is string and this is string. So we need not mention something like this, string S1 or something like this. This is not required. So he will just understand it. And this is the syntax. So these are the parameters. This is nothing but a function, kind of function. So this is a function, right? So S1 and S2, I'm just mentioning S1, S2. This means it will return something. So if you want to perform some logic, you can do it like this. So you perform some logic and then return. And then return. Okay, but if you have only the return statement, something like this, we only have return logic. So you can directly return this logic as well. So it will be S1 dot length. Let me copy it. S1 dot length is something less than S minus S2 dot length. Okay. With this, we are not required to write this entire boilerplate, which is the reason why Java is so difficult to understand from the beginner's point of view, because for one simple thing, you have to write 100 lines of code. Okay. So with this uh, okay, if you do the execution, it will be of same, the answer will be the same. Okay, so I'm just pasting this as well. Okay, so I am hoping that you are understanding the session is going good for you all. There is no, I'm seeing very few questions. So questions or doubts or concerns. That's why I'm asking you again and again. But if you have any doubts at any point, please try to put them in chat. I will be going through the chat always. So if there is any relevant question, I will immediately take it. Okay, now let's move on to problem solving. I have given you all these three sorting algorithms, right? Yeah, so let's move on to problem solving question now. So let's see what is the first problem solving question. So we have seen this, Java inbuilt feature also we have seen. Now find the minimum difference between any two elements. Okay, so this is the question. You tell me how you will sort it. I want answers from you now. This is the question. Given an array, so let's say 4, 3, 1, 0, 7, 6, 5. Okay, let's say this is the array. You have to find the minimum difference between any two elements. So understand the question. First step, minimum difference between any two elements. So what are the two elements that I can choose randomly? I can choose 4 comma 3, I can choose 4 comma 1, 4 comma 0, so on. Then I can choose 3 comma 1, 3 comma 0. I cannot choose 0 comma 0, so that will not happen because difference will be 0 in that case. And if I choose this, then 3 comma 0, something like that. Okay, 7 comma 6 or something. So these are all the valid combinations that I can have of selecting two numbers, two elements. So from out of all this combination, I have to find the minimum difference. Okay, what is the minimum difference? If you see, 7 minus 6 is 1, 1 minus 1 is, so 1 is the answer here. So there is no such combination which will give us 0. If there was 5 comma 5, then it will become 0. But let's assume this 5 comma 5 is not there. Okay, so the question is, given this array to you, you have to find out the minimum difference that exists between any two elements. So what is your approach? How will you solve it? How will you solve it? I need answers from you guys. First think, try to do a brute force solution, and then you try to optimize it. So for minimum difference, what are the things that we need? We need two minimum values or two maximum values, or what is it? Come on guys, answer. There are 162 members in this session, but hardly 7 to 8 members are replying. Sort and then find, subtract first and second element. We'll use two for loops. Okay, so okay, received how many? 4 answers, 5 at the max. Okay, so let's talk about brute force now. Let's try to solve it directly. So let's say public int get min difference int array. Okay, so it will so let me just print the value. This min difference it is get min difference. So it's like this. Get min difference. Okay, so this is how my answer is. So for now, let me let us do a brute force approach first. So first of all, just see how you can understand the question first of all. So it is asking you to find the minimum difference between two elements. So two elements with what are the combinations of two elements? So I can just write a two for loop and get the combination, right? So I can simply do it. So I'll say int min diff is equal to integer dot min value. So sorry, max value. So as I said in the first sessions only, if you're finding the minimum thing, you have to set the initial to the maximum. So I can say for int I is equal to 0, I less than ARR dot length I plus plus, and then for int j is equal to I plus 1, j less than dot length j plus plus. Okay, so it will now it will count it will iteratively calculate all the combinations. So first 0 comma 1, then 0 comma 2, then 0 comma 3, then 1 comma 1, 1 comma 2, 1 comma 3, so on. It will continue, and that will give us all the combinations. So in all the combinations, all we need is the difference. So how do I get the difference? So again, here if I have to remember, if the array is something like this, 6 comma 7, so I have to do 7 minus 6. Okay, but at the same time, if it is 7 comma 6, again I have to do 7 minus 6. I cannot do 6 minus 7. If I do 6 minus 7, it is minus 1. But here I have to do absolute value. So I'll just do it like this. Min difference is equal to math dot min of. Okay, what is the minimum of min difference? Comma math dot abs of ARR of I minus ARR of j. Simple. So it will just do all the things, and I will return min difference. Okay, first things first, what did math.abs is? Math.abs will return as the absolute value. If it is minus 1, it will return 1. If it is minus 100, it will return 100. If it is 100, it will just return 100. It will just give us a positive value. Positive value of what? The difference. Difference of what? Of two numbers. What is the two number? First number is ARR of I. Second number is ARR of j. So it will just do the difference and it will see. So now I have a difference. I have previous difference. So now I will see which one is minimum. So whoever is minimum, I'll assign it to minimum difference. So let's test it out. So let's give it some inputs like 7, 2, 6, 4, 2, 6, 5, 8, 10, 100, 1. Let's say 0. 1, 2, 3, 4, 5, 6, 7. Okay, so what is the minimum difference here? 6, 5 will give us a minimum difference of 1. So answer should be 1. Minimum difference is 1. If I don't have 5, let's say if I don't have 5, in this case, what is the minimum difference? 0 comma 2 is 2, 6 comma 2 is 4, 8 comma 6 is also 2. So it should be 2 basically here. So 2, it is working fine. But here the time, just consider time complexity. So we are manually doing all the comparisons and then we are seeing it. So all these comparisons will take your time complexity of n square. So this approach is having time complexity of n square. So can we further improvise it? Yes, we can. So what we can do is we can sort this array. Arrays, I'm using arrays dot sort simply. I'm just passing the array. Okay, once I have the sorted array, so let's do. So if this is the sorted, if this is the array given to us, what is the sorted value? 0, 1, 3, 4, 5, 6, 7. So now the minimum difference will not occur between the first two or second two or the last two or something like that. It might occur in this adjacent value. So difference is nothing but minimum difference with minimum number, two minimum numbers. So in here, if I consider 0, the next minimum number is 1. So if I consider 1, the next minimum number is 3. If I consider 3, the next minimum number is 4. All I have to do is calculate the minimum differences between these two guys. Okay, and whoever is the smallest will be having the answer. So I will do the same thing. So now in here I don't need this thing. I'll just put this one. Okay, so minimum difference minus ARR plus I plus 1, and it will go length minus 1. Let's do it. Execute it. See, minimum difference is 2, and if I give 7 and if I give here some 7, minimum difference should be 1. Yeah, working fine. So what did we improve? So the thing that we improved here is first of all, it is not n square. Now the overall time complexity of a program is n log n plus n, which is nothing but n log n. So as we all know, n square versus n log n is the most efficient one. So we have now optimized our program to n log n. Can we do it in n? So that I leave it to you. You can try thinking out of approaches where it will use n. So sorting, whenever you're doing, you have to also consider the time complexity of sorting. So without sorting, if you can do it in n, then it's very good. So everyone good with this problem statement? Everyone understood this problem solution first of all? Okay, let's move on to the next question. Guys, please reply. I'm just seeing reply from 2 or 3 members. Okay, let's move on to the next question. Minimum sum of two numbers formed from digits of an array. Array contains 0 to 9. Okay, so this is the question. Minimum sum of two numbers formed from digits of array. So the question here is similar. So it is warning. It is so the previous question was minimum difference. It is now asking minimum sum. So previous was minimum difference. Okay, so but the question is a little different now. Of two numbers formed from can let me answer a question. Okay. Okay, so formed from digits of an array contains 0 to 9. So the question is there will be an array given to you which will only have 0 to 9. Let's say like 1, 3, 4, 7, 6, and then 0, 1, 0, something like this. Okay, so if this is the number given to you, if this is the array element given to you, you have to first of all create two numbers from this array. Okay, two numbers from this array. So what could be the number? It could be 1, 3, 4, 7, 0, 1, 0. It could be 1, 4, 3, 7, 0, 1, 0 of any order. Okay, it could be 3, 1, 4, 7, 0, 1, 0, 4. Okay, or else it could be 3, 4, 1, or so on. So you understand, right? So from these digits, I have to create two numbers. So I have to create in two such numbers where the sum is minimum. Okay, that is the question. So in here, so out of this array, so this is nothing but an array given to you. So in this array, I have to find out two numbers in such a way that their sum is the minimum possible sum. I hope you got the question. Everyone got the question? Try to think of an approach and try to give the solution. So from this array, which is having only single digit integers, you have to find out two such numbers whose sum will give you the minimum, so whose sum will be the minimum. So you can use the digits in any random order if you want, but you cannot repeat the digits. If there is 3, you can only have 1 3 in your numbers. Try to give the answer, guys. So for minimum sum, what is the requirement? First requirement for minimum sum, my first smart move would be get two minimum numbers. So how do I construct two minimum numbers from that array? You have to find out two numbers, guys, and the important step here is you may take any number. You can take 1, and you can take 0, and you can take 4. Okay, let's say 14104 is my first number. Second number is 37. I can take in any order, then 0, 0, something like this. Okay, I can take in any order, and I have to make these two numbers in such a way that their sum is minimum. Think of a solution. How will you do it? Okay, let's see the solution. So let me minimize this. Public static int get minimum sum int ARR. So this ARR was different. This ARR was having all the numbers, but here it is only consisting of digits. Okay, so my approach here is what we will do here is we will sort this array. Okay, so let me copy this thing. So why do I want to sort it? So the base understanding is, or the first smart move that we have to do is, we have to find out two smallest number. So the sum of two smallest number will always be the smallest possible. So how do I get the two smallest numbers? So let's say I have sorted it 0, 0, 1, 1, 3, 4, 7. If this is the number. So smallest number by definition should have the smallest possible number in the left side. Okay, so if it is 1, 2, 3, if these are the three digits, so what are the possible combinations? 1, 2, 3. Let's say these are 3. So I can have 1, 2, 3. I can have 1, 3, 2. I can have 2, 3, 1. I can have 2, 1, 3. Okay, they are 2 power n combinations. Then I can have 1, 2, 3. Then I can have 1, 3, 2. So out of 3, 2, 1, and then 3, 1, 2. So out of all this combination, which one is smallest? This one is smallest, 123. If you see it is 123, it is going into 30, and it is incrementing the 200 series and 300 series. Okay, so this is the smallest. How did I say? Because if you see, these are all sorted in ascending order. So this is my smallest number. This is the next smallest number. This is my next available smallest number. So I have to create two such numbers in which this properties lies out of all these digits. So what I can do is I have to create two smallest numbers. So can I do like this 0, 0, 1, 1 versus 3, 4, 7? If you see, this is smallest and this is also smallest. Can I do like this? Do you think this is correct? This is also not correct. So the correct answer should be, so if you see, we are reaching 300 series. So 300 series plus 11, what will be the answer here? Something around 358. So this 358 is the answer for this solution, but this is not correct. So there are still minimum number that we can do. So first thing first, we will take the first minimum number from this thing, then the second minimum number, then first minimum number, then again second minimum number, then again 3, then again 4, then again 7. If you see, if this is the number, then we are having 137 plus 14. It will be what? What is it? 7 plus 4 is how much? 11. So it will carry. So it is 150, 151 something. So 134, 017. So yeah, 134 and 017, both will give the same answer. So yeah, so just calculate this 137 plus 14. It might be something like this, 157. And if you see, it is less than 151. So this is not the way that we can take. We cannot just split the array into half, take the first half and take the second half. No. Instead, we have to take the first minimum number, assign it to the first number, then again the next minimum number, assign it to second number. Alternatively, we have to give so that we have the smallest number possible. So these are the two smallest number possible, and the sum of them will be the smallest. Did you get it? Did you all get the approach? Do you want to see the code, or you can do it on your own? Tell me guys, should we discuss the code, or you can do it on your own? Okay, there are people still who are requesting for the code. We will quickly go through it. So the first things first, we will sort the array. Okay, then we will have maintain two number. Num1 is equal to 0. Num2 is equal to 0. Then I will go through the sorted array. Int I is equal to 0, I less than n, I plus plus. If my I percentile 2 is equal to 0, that means if for all the even numbers, if you see this number, this number, and this number, and this number, this will be part of the first number. Then all the odd sequencing will be a part of the second number. So I have to increment the count. So num1 is equal to num1 into 10 plus ARR of 5. The same logic is here. Num2 is equal to num2 into 10 plus ARR of 5. Okay, so it will have number and num2. So I will just return num1 plus num2 minimum if sum is run. So let's do this. Minimum sum. Get minimum sum. Get minimum sum. Okay. Now let's give him some values. Let's give these values only. So 1347010. 1347010. How many elements are there here? 1, 2, 3, 4, 5, 6, 7. N is not there. See 151, and that was the answer, 151. Okay, so this is the code, guys. So we are just sorting the number. We are creating two numbers. How are we creating? We are just taking the first, as I explained you have to take the first available smallest number. For zero, you have to assign it to the number one. Once you have assigned the number one, so number one is having some value. So now the number two should have the next smallest number. So alternatively, you have to go and you have to create these two numbers. And how do we create an integer number? You all know this logic. So this will just keep on adding the digits to the number. Okay, just go through the code and let me know if you have any questions. Any questions, guys? Did you understand the approach? Can you move on to the next question? Okay, let's move on to the next question now. So the next question that we'll see is this thing, sort the array according to the frequency. Okay, this is an interesting question. So you are given an integer array, okay, which is of some of random order. Say 1, 2, 2, 4, 3, 2, then 3, then 5. Okay, let's say this is the array. So you have to sort them in terms of the frequency. So what do you mean by frequency? Frequency is nothing but the number of times this element is repeated. So the element that is repeated least number of times should be present at the beginning, and the element that is repeated most number of times should be present at the ending. And if both the elements are having same frequency, they should be sorted in ascending order. Okay, that is the requirement. So the answer to this thing will be, what is 1 is repeated one time, 2 is repeated many times, 4 and then 1. So it should be in sorted order. Let's say even if the array is not in this order, let's say it is 8, let's say. Okay, so what are the frequency? Here it is 1, here it is 1, here it is 1. So all this should be at the beginning. So even in this even in this 3 element, which should come first according to the ascending order. So 1, 5, 8. Okay, then it should be 3 because 3 is repeated 2 times, and then 2 is repeated 3 times. So this should be the answer. So you have to sort the array in according to the frequency. How will you do it? Think of an approach. Come on, guys. If the question is clear to you, think of an approach and how will you sort it. So this is not a normal sorting. It is sorting according to the frequency. So you have to do two things here. First thing is sort according to frequency, and then sort according to the ascending order also. So if you see 1, 5, 8, this should be the exact order. You cannot have 8, 5, and 1. Finding frequency of each number and store them in an array and do the sorting. Okay. Come on, guys. Answer. Only one person have tried solving it. First, think of it. Just divide your problems into smaller parts. So first, think of a solution which will help you in this part. So let's consider which should help you in this thing. So 1, 5, 8. So how will you do this thing? So is normal sorting, will it help or not? So try to think of in that terms. Yes, so in here there are two ways to do it. First thing, if you know Java, you should know the concept of hash map. Okay, it is nothing but technically we are maintaining the count. So if you see this array, let me copy it. The first thing that we need is how many times that array the number is repeated. So 1 is repeated 1 time, 2 is repeated 3 how many times? 2 times. 8 is repeated 1 time, and then 3 is repeated 2 is repeated 3 times, 3 is repeated 2 times, 5 is repeated 1 time. Okay, we need this data. So once we need this data, once we got this data, first of all we have to sort them according to this number and again according to this thing. So in both the cases we have to sort according to the numbers and according to the count and according to the values. So how can we help it? So the first step that we can do is we can initially sort this array. So the array will be 1, 2, 2, 2, and then it will be 3, 3, then 5 and 8. Okay. So the intention of us of sorting it is, so now when we count, now when we keep a track of this value, so we know this part will be sorted. So 1 is repeated 1 time, 2 is repeated 3 times, 3 is repeated 2 times, then 8 1 time, 5 1 time. Okay. So now this is sorted. Now once this is sorted, all we have to sort this value, okay, according to this thing. So in Java, there are concepts of where you can sort a hash member according to the value. Once we sort them, let's say we have sorted it, so it will come 1 1, then 8, sorry, 8 is 5. So it is 5 1, and then now we are sorting according to the frequency. So 1 will come here, then another one. So what is the next one? 5, then another one. What is the next one? 8, then 2, it is 3, then it is 3, it is 2. So once we have this data, I can simply go in my array and I can change the value. So I will just add 1 1 times, then 5 1 time, then 8 1 time, then 3 2 times, then 2 3 times. I can just modify my update. So this is how we can do it. So first, if you know Java, all you have to do is maintain this thing. Then you have to sort it according to the values. But what if you don't know Java? Even if you don't know Java, this is nothing but a key value pair. That is nothing but you can maintain a 2D array basically. Okay, you can maintain a 2D array which is holding these two values, and then sort according to the value. So you can, if you can do that, you will easily get this sorted in the frequency. Did you understand the approach? How you can do it with hash map? How, why are we counting it? Why are we sorting it initially? So the first step, let me write the algorithm. Step 1, sort the array. This will help in the case when two numbers are having same frequency. See, so in that case, we need to sort them in ascending order, right? We need to sort in ascending. That's the reason. That's the reason why we are doing this. Okay, now once it is sorted, count the frequency. Count and store the frequency. Okay, once the frequency is stored either by using hash map or 2D array. Okay, either by using hash map or either by using 2D array. Okay, then sort the hash map or 2D array by value. Then go through the sorted collection. Go through the sorted collection and fill the array, initial array. Okay. So this is the pseudocode. So now let's try calculating complexity. For sorting, it will be n log n. Okay, this is space. Time complexity. This is space complexity. Sorting, it is not required, so it is order of 1 only here. Now count and store the frequency. So this will take n, but the space will also grow to n. Now again sort it. So sorting can be done in n log n, and this is constant space 1. So go through the logic and fill the array. So it is n. So in here, if you see, our overall logic or the overall complexity will be n log n only. So the biggest. So n log n versus n log n is more. N log n versus n log n is more. That's why the time complexity will be n log n. Space complexity will be order of n. Why? We are using a hash map or a 2D array. That's why. So this approach, this solution can be done in n log n only. Are you guys clear with the approach? How you want the solution to be discussed? So first thing first, note down these points so that you can go through it. So note down this point. You try it on your own. If we are getting some issues, we will see in the next class. But I want you to try it on your own. Why I am saying it? Because people who know HashMap can work with HashMap a little bit and understand how HashMap is done and all. If you don't know HashMap, if you don't want to use a map, use a 2D array. And using 2D array also, you can sort the 2D array. While sorting the 2D array, so this will also cover one problem statement is how do you sort 2D array. So it will cover that one also. So while sorting 2D array, you have to consider the count. So count is stored in the first index. So based on that, you can just sort the array. And once you have sorted, the solution is done. So all you have to do is go through the array. Okay, just note down these points and try it on your own. If you feel any problem or if you want the solution to be discussed, we can take it in next class because today is almost done. But first of all, take this 4 points. Take a note of this take a note of this algorithm basically. Okay, so try out that logic. Let me give you some uh, input so that you can work with it. So if the input is 1 comma 2 3 3 3 8 9, so the input is this, output should be this. 1 is repeated 1 times, then 2 is repeated 2 times, 2 is repeated 3 times. Okay, 3 is repeated 8, then 9 comma 9, then 2 comma 2 comma 2, then 3 comma 3 comma 3. This should be the output, one input and output. If the input is 1 9 9 8 8 8 7 7, the input is this, output should be the first one because it is repeated only 1 times, then 3, then 7 comma 7, then 8 comma 8, 1 comma 9 comma 9, then 2 comma 2 comma 2. Okay, so these are the two inputs. Try to work out your solution. So see that if these two inputs are matching or not, input or output are matching or not. So just try it out, guys. I want you to work on this problem because it will, first of all, it will help you understand sorting in details. So I will suggest you to go with the second approach, the 2D approach, 2D array approach. So if you see HashMap is nothing but key value pairs. So if you are maintaining key value pairs, it is nothing but a 2D array where each row is having two values. First value is nothing but the key, second value is nothing but the column. So we can just represent it as 2D array and sort it. So I want you all to go through and solve this problem. And if you are facing any problem, we will see it in the next class. So I think with this, we can finish today's session. So next session, we will talk about quick sort and merge sort and problem statements on them. We will see the time complexity and space complexity of both these sorting algorithms. Okay, so let me know if you have any questions. If not, we are good for the day. Come on, guys. Did you follow today's question? Okay. I'm hoping that whatever I'm trying to teach here, you guys are understanding it, and you're getting some help from that. So try to utilize this platform, guys. Uh, so whatever question you have, try asking them. Uh, if you don't want to ask them, or if you want to do a research on them, go through it. But even after the research, if you want some clarity, please ask us here. Utilize this platform because you will not get platform like this again and again. So just make best use of the opportunities that is coming to you. Practice all the programs and try to solve this program basically this sorting according to the frequency one. Okay, so I don't see any further questions in the chat, so that so we will close the session now. So thank you all for joining. Have a good day.